Hello everyone. Have you ever wondered if someone is trying to connect to your AWS resources without your knowledge? Well, you can actually track that using the VPC flow logs in AWS. But before we jump into the demo, let me quickly explain what a VPC flow log is. So, the VPC flow log is a feature that captures the information about the IP traffic going to and from the network interfaces in your VPC. You can think of it like your home Wi-Fi logs. If someone tries to connect to your Wi-Fi, you can see their device in the logs, and if it is unknown device, you can take the action and block it. So similarly, in AWS, VPC flow logs show who is trying to connect from which IP and whether the request was accepted or rejected. They don't block the traffic directly, but they give you visibility. And yes, you can block the suspicious traffic later using the WAF, which is a web application firewall, or NACL, which is a network access control list. So in the second part of this video, I will show you how to block the traffic using the NACL. But in this video, I will focus on showing you how the VPC flow logs works. So in simple words, VPC flow logs are like a CCTV camera for your AWS network traffic. They don't stop the intruders, but they show you exactly what's happening. So let's see how to set up the VPC flow log. After logging to AWS Management Console, we have to go to the VPC. Here I am creating a new VPC. If you want a detailed explanation of how to create a VPC, you can check out my previous videos. I will also drop the link in the description. So after creating a VPC, let's create a public subnet. So in the subnet settings, you have to enable the auto assign public IPv4 address. Now let's create one private subnet also. So now I am creating the internet gateway. Then click on attach to a VPC. After that, let's create one public route table. Then we will associate it with the public subnet. And then add a route to the internet gateway. So now we are done with creating the public subnet, attaching the internet gateway, and adding the routes in the public route table for the internet access. Now let's set up the internet access for the private subnet. For that, first I am creating the NAT gateway inside the public subnet. Click on allocate elastic IP, then create the NAT gateway. Now let's create a private route table. Then let's associate this route table with the private subnet. After that, in the routes, for the destination I am adding the 0, which means the traffic going to anywhere on the internet. And for the target, select the NAT gateway that we just created. So this way, all the outbound traffic from the private subnet will go through the NAT gateway in the public subnet. So we are done with setting up the VPC. Now let's launch our first EC2 instance, naming as bastion host inside the public subnet. So here for the instance type, I am selecting t2.micro, which is in free tier, and moving without a key pair. Then in the network setting, select the created VPC, which is test VPC. And public subnet, you can see the auto assign public IP is enabled here. So renaming the security group as bastion host security group. Then click on launch instance. So after creating the bashan host instance, refresh it once, then select the instance and click on connect. So after connecting, switch to the root user using the sudo -i. Then let's test the internet connectivity by running ping google.com. So as you can see, it is accessing the internet. Now let's create one more instance using the private subnet, naming as private host. And for the instance type, I am again choosing t2.micro. And for the key pair, let me create a new key pair, naming it as new. Then edit the network settings. Make sure to select our created VPC, which is test VPC. Select the private subnet and rename the security group as private host security group. In the inbound rules of the security group, I am allowing the SSH, but instead of allowing it from anywhere, let me make it custom and allow the SSH only from my bashan host. So in this way, the private instance cannot be accessed directly from the internet. It can only be accessed securely through the bashan host. So after launching the private instance, let's go to the terminal and copy the key that we have created just, which is the new.pem. So now inside our bashan host, we will create a new file using the vi. I am naming it as new1.pem. So inside this, press I to insert and paste the copied key content. Then save this file. After that, change the file permission using the chmod. Before we continue, let me quickly explain why we are creating this key file here on the bashan host. So when we first launched the private host, the key pair was downloaded in our local downloads folder. As we are inside the bashan host right now, we cannot directly access the local downloads folder from here. So that's why we copied the key content manually and created a new file inside this bashan host so that we can use it to connect to the private instance. So now let's copy the private IPv4 address of our private host. Then inside the bashan host, run the SSH command with the key file we just created, that is ssh-i new1.pem ec2-user@. Then paste the private IPv4 address. As you can see, we have successfully connected from the bashan host to the private host. After switching to root user, let's check the internet connectivity from this private instance by running ping google.com. As we have added the NAT gateway in our setup, the private instance has the internet access and the ping is working. Now that our setup is complete, let's move to the main part, which is creating a VPC flow log. Go back to the VPC dashboard, then select your created VPC, which is test VPC. Then below you will find a flow logs option. Then click on create flow log. Here you can configure where you want the logs to be stored. We will first create a flow log for Amazon S3. So for the name, I am giving it test VPC flow log S3. Under the filter, I am keeping all, so it captures both the accepted and rejected traffic. For the maximum aggregation interval, I am setting it to 1 minute. And for destination, select send to an Amazon S3 bucket. Since we don't have a bucket yet, let's quickly create a new one. Click on create S3 bucket. Give it a unique name. Remember, the bucket name must be globally unique. So it is not a unique name. Let me rename it. So once the bucket is created, we have to copy the Amazon resource name, which is ARN. Select the bucket, then click on properties. So here you will find ARN, copy it. Go back to our VPC flow log and paste it in the S3 bucket ARN. After that, you will also notice a format preview here. This shows the kind of information the flow logs capture, which is your account ID, then interface ID through which the traffic flows, source IP address, destination IP address, and source port, destination port, packets, bytes, start, end, and lastly, status. I will provide you the detailed information about this in the description. Then click on create flow log. After creating it, if we go to the S3 bucket, you can see it has started generating the logs here. Now let's create a VPC flow log for the CloudWatch. Go back to the VPC, select the test VPC, then click on create flow log. I am naming it as test VPC flow log CloudWatch. Setting the filter to all to capture both accepted and rejected traffic. After that, I am setting the maximum aggregation interval to 1 minute and destination is send to CloudWatch logs. After that, we have to select the destination log groups. For that, search for the CloudWatch, or you can also bookmark these services for the easy access. Then in the left section, you will find the option log groups. Click on create log group. I am naming it as test VPC flow log CloudWatch. So for the testing purpose, I am setting the retention to 1 day. This determines how long the logs are stored before automatic deletion. But you are thinking that why I am creating this log group here. The log group acts as a container where all the VPC flow logs will be stored in CloudWatch. Okay, so click on create. Once the log group is created, go back to the VPC flow log. Refresh it once. You will find in the drop down the log group that we have created just. And for the service role, we have to create the IAM role here. In the search bar, type IAM. In the left section, select roles. Click on create role. Then I'm selecting custom trust policy. In that, under the principal, add service in double quotes, then colon, and again in double quote, 𝗵𝗃-flow-logs.amazonaws.com. So this allows the VPC flow log service to write the logs on your behalf. Click on next. Here we have to attach the CloudWatch full access, which grants the permission to create the log streams and write the logs in the log group. Then enter the role name and click on create role. This is the important step to create the IAM role. Without this role, the VPC flow logs cannot send the data to CloudWatch. As you can see, the role is created here. So go back to the VPC flow log, refresh, and you will see the newly created IAM role here. So after that, the format preview remains the same as S3. Then click on create flow log. Now if you check in the VPC section under the flow logs, you will see two flow logs, one for S3 and one for CloudWatch. If we check the CloudWatch log groups, under that in log streams, it will generate the first log based on the traffic. So after creating the VPC flow logs, let's analyze them using the Amazon Athena. In the AWS search bar, search for Athena and open the service. So this is the query editor where you can run the queries. Meanwhile, open a new tab in your browser and search for create table for Amazon Athena VPC flow logs. Always follow the official AWS documentation. It is most reliable source. Then copy the first query from the documentation, which is create external table if not exist VPC flow logs query. And in Athena's query editor, paste the query. And here for the location, we have to specify our S3 bucket where the VPC flow logs are stored. We have to specify the path till the region code. For this, go to S3 bucket. So in S3, these appear as folders, but technically they are prefixes. So we have to navigate till the region code. Click on properties and copy S3 URI. Then go back to the query editor. Then select the location and we have to paste that copied location. Then click on run. As you can see, we have successfully run this query. But here is one main thing. As far as we run this, the Athena will automatically create a results bucket in S3. As the Athena needs a bucket to store the query results, because the queries in Athena are serverless and the output has to go somewhere. You can also check it here. We have created the S3 bucket only for flow log. So for the next, go back to the AWS documentation. And here we have to copy alter table VPC flow logs query. And again paste it into the query editor. Again it is asking for the location. So we have to go to the S3. Select the right S3 flow log bucket, not the Athena bucket. So here we have to copy S3 URI till the date. Then go to properties, copy S3 URI. Then go back to query editor, update the location in the query to include the path in the S3 bucket up to year, month, date. Also change the above date. Year is 2025 and on month 09 and date is 12. Then click on run. So this updates the table with the correct location of your logs. Now we can query the logs. For that, copy the select query from the AWS documentation. Paste it into the query editor and click on run. So this will show up to 100 rejected traffic records from your VPC flow logs. So it is showing the result as per the query. So as you can see here, the interface ID, it may not exactly match with our instances if the traffic is from other source. As you can see, it is showing only the rejected traffic because we have added only reject in the action. I am changing it to accept to see the accepted traffic here. You can also adjust the limit to any number you want. After clicking on run, the query displays the accepted traffic with the details like day, date, interface ID, source and destination address, then action and protocol. Now let's go back to our EC2 instance and check the ENIs, which is the Elastic Network Interface. First we will check the private host ENI. Below in the networking, you will find the ENI. Note that ENI ID, the last digits are 69BF. Let's go back to the CloudWatch. In the log streams, you will see the ENID listed. So the first one has the last digit 69BF. Notice the all at the end, which indicates all traffic. Now let's see the ENID of Bastion host. In the networking, there is a ENID which has the last digit 66B6. So it is also present in the CloudWatch log stream. Let's click on the first ENI, which is of private host. You will see the log events here, which has both accept and reject traffic. If you click on any log preview, you can see the version and the account ID, which is same as my account ID. Then the interface ID, which is same as private host ENI. Then the source IP address, which is sending the traffic. Then destination address, which is the private IPv4 address of our instance. And the rest are the packets, bytes, start, end time, then action, which is accept or reject. After that, status, which is OK here. You can similarly check for the Bastion host ENI. It also shows the accept and reject actions for the traffic through that ENI. And the destination IP is correspond to Bastion host private IP. So that's it for today. In part 2, I will show you how to block unwanted traffic using NACLs. So stay tuned. Once you are done, don't forget to terminate the instance and delete the created VPC to avoid unnecessary costs. Lastly, if you have any questions or doubts, feel free to ask them in the comment section and stay tuned for second part.